Okay. Well, I hope you guys are doing well. So regarding visualizations in R, I was going to just do another demonstration and not complicate things any further. We were just going to stick with scatter plots, and I wanted to introduce maybe the element of time or something, or it doesn't have to be time, but that's one variable that I think we can relate to or understand readily, and so I was going to try to recreate some of the graphs that we might see in at a site like Gapminder. So have you guys heard of Gapminder? Okay. Yes, no? All right, so some of you guys have. You guys have heard of TED Talks? Okay, so there was a TED Talk that was very popular. It's probably like 10 years old now, with this guy Hans Rosling, and there he is. He's showing some kind of some demo here, and so this is kind of the display that he has, and so it's a scatter plot, and this is a scatter plot showing the relationship between income per person or GDP per capita versus life expectancy for a bunch of different countries. Okay, so we're looking at one nation to another nation. All right, and the size of the circles is the population of that country. So this big blue circle is India. This big red circle is China. Okay. The colors of the circles are related to the geographic region, and so we've got yellow for the Americas, North and South. Blue for sub-Saharan Africa, and green for the Middle East and Northern Africa, and blue for South Asia, primarily India and Pakistan, and Australia and Southeast Asia or East Asia, and then Europe is in orange and things like that. And you get these cool demonstrations, and so this shows kind of how over time, this is in the 1920s, we see. You see, like, you can follow the trail of the big red circle, which would be China, which shows income per capita increasing over time. So that means let's just reverse again. You can see pretty much life expectancy is kind of going up across the board. We get a little bit of bounciness, but overall everybody's their life expectancy is getting longer and longer, and as soon as the 2000s hit, the income per capita for China and India, we see these increasing and things of that nature. Okay, so it's a cool thing, and when if you haven't seen the TED Talk, you can look up TED Hans Rosling, and this is probably the one right here, the first one that hits, and yeah, it's 10 years old now, and it's a 20-minute talk. I recommend it, even though the video is 20 years old. He kind of demonstrates the use of his tool here. Okay, and so it's a very neat, I think a neat way to show visualizations. Okay, and time is kind of this natural is a natural extra dimension that we can show how things have changed over time. Okay, so just looking at from 1980 and so on and so forth, we can see huge changes even in the just last 30 years, looking at life expectancy and income and all of these things. And so the U.S. in the 90s and in 80s, is in the upper right-hand corner. We can see huge movement for China and India as their economies have drastically changed, with the as they become kind of up and coming leaders in technology and service. So we can see that demonstrated here, and I was going to show how we could kind of recreate something similar in R. Unfortunately, I'm having trouble getting the animation component to work. But just getting the data into R and cleaning it up into a form that you can graph and use is a non-trivial matter. So I guess I can spend some time here and talking about using packages like tidyr, packages like dplyr to manipulate our data. And so with Gapminder you can download the data. You just go to the data section, and whatever it might be. So if we want to download income, we'll say income per person. Here we have it, GDP per capita, which is this this data that we have here. I can download it as an Excel file, okay? And if I were to open up the file in Excel, it looks like this, but it contains all of these other sheets, and it may or may not be quite suitable as it exists just the way it does here. Okay. Now, to get data like this from an Excel file into R, R doesn't natively read Excel files, and so we have a few options. One is to open this up in Excel or some other spreadsheet program and then export it as a CSV or tab delimited file or something that R plays nicely with. And that's a perfectly valid option, although I recommend trying to get, using a package with R to try to get your data into R kind of directly from the Excel file. And the reason for that is that, if you have to open it up in Excel and then export it as a CSV or something like that, that is the use of two separate programs, okay? And so it just means if you wanted to get new data into your system, you would have to download the new data, open it in Excel, and then do this process. And so there's kind of this manual aspect involved. Now, if you can read it directly into R, then all you have to do is at most edit the text files, or I mean the commands to read it in, and so you can kind of automate the process just with text. Okay, and so we have a few options to get Excel files into R, and one of them is Excel Connect. Okay, and so to get data into R, you can do install.packages Excel Connect. Okay, this is the library that I'm going to use, and if I started off, so all of these things that you run into, you could run into problems, and the way you solve problems is with Google. So if when I first ran this thing, okay, I downloaded the relevant worksheets. So I downloaded, I went to Gapminder and I said, okay, I want the thing for GDP per capita, and I also want it population, and I also want life expectancy at birth. These are the different things that we were gonna graph, and we're going to combine and plot today. And so I downloaded these and I saved them as just as they appear. Now let me restart my R session. If I just load the library as it is, and then I try to load the data. Oh, it worked. Well, when I first ran it, I ran into a problem, and I kept getting this memory error issue. And so whenever you get an error, what you do is you go, you just highlight the error that you get, and then you go onto Google and you search for that error. Hopefully, you're hoping that someone on Stack Exchange says, "I had the same problem, and this is what's going on." And I know we joke and we laugh, but that's probably 90-something% of your errors can be solved in a similar fashion. Chances are, when you come across an error, this is not the first time this error has ever appeared in life, okay? And chances are someone else had the same error and said, "Hey, I need help," and you can search either these message boards like Stack Exchange or whatnot. Okay, so anyway, when I tried to load it, I guess I've already changed the options. It gave me some kind of error, and so my search on Stack Exchange says, "Hey, just load this, put this little option in, and this will fix the memory problem with Excel Connect." Okay. Okay, and so it works now, and I can get these files in. Okay, and we can take a look at any of these things, and I can just say I'm going to load library dplyr and tidyr. Okay, these I will use to kind of clean up and combine our data into something that's easier. And so one thing we can use is str to observe the structure of the data that I have. And so I can do structure of income, and we see, oh gosh, that it looks kind of messy. And if I were to click income itself, this is what it looks like. Over here it lists the country, and across the head, I don't know if you guys can see this, are the different years, okay? And the number here would be the quantity that we're interested in, GDP per capita, okay? And so what I want to do is I want to change all of these things, and I want to instead make the column, I want to combine all of these data sets. So I've got one for income, one for life expectancy, and one for population. I want to be able to combine these things so that my data set is just going to have 3 columns, okay? Well, more than 3 columns, but we're going to have a column for life expectancy, column for income, column for population, and then each row will be a country and the year. Okay, so it'll say something like Australia in 1980 this was their life expectancy, this was the income, this was the population. Australia 1981, these were the 3 values. So I want to combine them in such a fashion. Okay, and so to do that, what I want to do is I want to use the library tidyr and gather the columns together. Okay, and so here, I've kind of just used the default naming conventions that show up in the example for tidyr, the gather command. But I could rename the end to something like income or whatnot, okay? So again, let's take a look at income. And so I'm going to combine this into one basically, I'm going to take all of these columns that say X 1800, X 1801, X 1802, and I'm going to take all of these columns and turn them into one column, and it's going to have a kind of a key value pair between the country and the year. Does that make sense? Maybe I will demonstrate it here, okay? And so I'm using the command gather, and we're going to apply it to the income table. And this is the name of the key, which will be year, and then the value I'm just calling N here, okay? I guess it should actually be income. And what we're going to do is we're going to gather the columns, the 2nd through 217th column, which is kind of, pretty much everything but the first column. I'm going to remove any values that are missing, and then I'm going to have tidyr convert the data into either strings or numbers or however it sees fit. Okay, and so when I run the command, it's like instantaneous. Okay, and I can then ask, okay, let's just take a look at what our income looks like. Okay, all right, and so what we see is indeed it has basically taken this entire column and said, okay, we're going to take the year and call it X 1800, and then each of these things, so Afghanistan 1800 had an income per capita of 603, okay, and then in 1801 it was also 603, and 1802 is 603, and we can see if I were to scroll all the way down to 1801, we see these values, and so they probably just maybe we'll see the difference in Andorra. In 1800, Andorra had an income of 1197 per capita. In 1801, it was 1199. In 1802, it was 1201. Okay, and so we can see again scrolling up, and Andorra X 1800 was 1197, and then scrolling down a couple hundred rows later, we can see Andorra again, 1801, 1199. So what we've done is we've gathered these columns together. Okay, there's a very handy cheat sheet. You just look up the tidyr cheat sheet, and this is I don't know if this picture captures what I'm doing. Well, it does, but we are taking the columns and we're turning them into basically just a single column of values with another column taking the column headings here. Okay, and so that's gathering with tidyr. And I'm going to basically just do the same thing for life expectancy and population. Okay. So we've used so far what we've done is we've used Excel Connect to read in our data directly from the Excel file, not needing to convert anything. And then we are using tidyr to turn our wide tables into kind of narrow, long tables, okay? So I'm combining on our life and our population. Okay. Okay, and so I have r underscore to kind of say reshaped, and so we can take a look at any of these. And so so our income table, we've seen the reshaped income table. The reshaped life expectancy table looks as such, and the reshaped population table also looks like this. Okay. Now what we notice is that we have these artifacts of the way Gapminder stored the data, okay? And we should rename our columns so that the first one says country, the second one says year, and the third one has the name of the value we're storing. So this third column should say GDP per capita. okay? Over here, this should say country, year, life expectancy. And over here, we should have country, year, population, okay? So that's a very simple fix to do in R. And that's just, we use the names command, okay? So I can ask, what are the names that exist in R income? And it says these are the names that we have, okay? And so what we want is for income, we want to rename it country, year, GDP per capita, okay? And so I'm going to run these commands, and this just renames our column names, column headings, so that when I look at them now, indeed it will say country, year, and GDP per capita, or the variable that we want. Okay, so this is very straightforward. And then the other thing is that in order to apply the appropriate filters that we want to do for something like year, because of the way R reads in the data, one of your object naming rules in R is that your object can't start with a number, okay? So you can't name something 1800. And because of that, the column headings got either the messed up. Well, actually, I'm not 100% sure if that's the reason why the column headings came in with X 1800. It's also possible that the way Gapminder stored their data, there's just something funny about the storing of the year. Maybe there's I don't know, a space or some other character that's illegal, so it gets replaced with an X. I'm not sure. But anyway, we just want to replace each of these things. We just want to get rid of the X in the front here, okay? And so we just basically want to go through and say, get rid of the X, all right? And so we're going to use regular expressions to do this, okay? And so to do that, I'm going to use library string R, all right? So, if you were in my 102A class, these are all kind of things that we were exposed to. And so using the regular expression, the pattern that we want to, so we've got something like X 1800, and we want to replace this with just 1800, okay? Now the way regular expressions work is that it tries to match the entire thing. And so you can't just say, find and replace X, replace anytime you see an X with a null character, because it doesn't work like it does in Excel or Word, where it just goes through and strip these things out. You got to kind of take the entire match and say, this is what you're matching, X 1800, and I want you to replace it with 1800, okay? So essentially, what we're going to try to do is we're going to try to match something in the form of X followed by 4 digits, right? And I'm going to put this in parentheses, so we're going to say 4 digits. And then what we want it to do is we're going to replace it with just those 4 digits, whatever they are, okay? So our regular expression is going to be match the capital X, and then we say, find a digit, which is a /D, and I'm just going to put a plus, which just says match 1 or more, okay? So I guess I could specify I want you to match exactly 4 digits, but we're going to just say, hey, find a digit, 1 or more digits, and I put it in the parentheses to group it, right? Okay. Do I need to review regular expressions? I'm not sure. Okay, yes. So I'm getting some head nods here. Okay, so regular expressions. So, I guess I realize. Okay, well, let me pause and just say a few things. So I know our TA is going through a lot of matrix stuff, and that's because I told them to cover matrix stuff. And I know in class I'm not covering matrix stuff at the moment. We will get to matrix stuff. I know you guys are looking forward to that stuff again. We'll get to that eventually. All right. And I also know I said a lot of the notes for the class were based on Professor Joe's notes. Please don't bother Professor Joe asking him for a copy of his notes, okay? That's not, you know, he shouldn't have to juggle these requests. And I promise you, whatever notes you need for this class, I will provide. I will post them, and I will provide them. So you don't have to worry about going to someone else trying to get notes for this class. If there's notes that you need for this class, I promise you, I'll provide them at the time you need them, okay? So just trust me on that for now. And then I know I have to create homework assignments and assign them. And so I'm trying to think of an interesting homework assignment that will focus in on displaying multivariate data. And so I'm working on that. When I have that ready, I'll post that up as an assignment for you guys. But I know I'll have to figure that out, okay? And I promise I'll be fair and you know, I'm not gonna like post up an assignment and make it due the next day or anything like that. I promise, you know, if I give you an assignment, you'll have adequate time to finish. So everything will be okay, all right? Okay, so anyway, you know, regular expressions, we can match. So yeah, you know, I don't want to spend an entire lecture on regular expressions. I guess I can post. This is the so this website is super in depth on regular expressions. Where's my regular expressions cheat sheet? This is what I do. I just say, well, find cheat sheet, right? Okay, so this is basically, you can just say, you know, search for digits, search for these things. And so, you know, I want to match a digit. Now, one thing we have to keep in mind is that in R, you have to double escape. You have to escape your slash symbols here, okay? So what I want to do is this is the string pattern that I'm matching, which says match X, which is just kind of a literal X match, okay? And then match basically a digit character, that's the //D, and then the plus here means one or more, okay? So this says match X and one or more digits. And then I put that in parentheses to say whatever one or more digits that you find, group those together. And what we can then do is refer back to those with /1. This means the first group. So you could have multiple groups in a regular expression, and it will, you know, /1 will represent the first group that matches, /2 will represent the second group. Okay? So if we just look at R_income $year, let's just look at the first 10. Okay? We see X 1800 matched all of these times. Okay? So I can just kind of test this out and say, all right, we're going to try string replace on, you know, these values that we have. R_income $year, 1 through 10. Okay? All right, what is it that I'm trying to match? We're going to say we're going to match X followed by one or more digits, and we're going to try to replace it. And we could, you know, we can test out different things, but this is, I want to replace it with the first pattern that gets matched. And of course I get some kind of error here, so let's see. Oh, I forgot. this thing to close off my parentheses. Thank you. Okay, and this does the pattern that we want to do. It replaces it with 1800. Okay, so just to kind of illustrate, how cool regular expressions can be, we can say, here's the pattern that we're matching. Okay, the text. Maybe I'll punch in a phone number. Okay, 310 parentheses. Whoops, I clicked something. Space, 825-1234, okay? And we can say, all right, what we want you to match is 3 digits, okay? So to match the parentheses here, we're going to say, I keep touching something here. We can just say, okay, match digits, 1 or more digits, and let's just see what it is that you find. Okay, so we're going to just group the first group of digits here, and okay, and it says, oh, I found all of these things. Okay, now we can give it a well. Now this is becoming a tutorial on okay, you know what? Sorry, we're not going to do a regular expression tutorial at this time. Okay, I'll post. So in 102A, I had a lecture on regular expressions, and I'll post a link to that video if you want to watch through that thing, along with the notes for that. Okay, if you need a refresher. But this cheat sheet will probably answer 90% of your questions as soon as you're familiar with the base idea of regular expressions. Okay, so anyway, we do this, we clean up our data, and now we can take a look and just make sure that the using glimpse, which is kind of like a structure of a thing, except I don't know, the format comes out a tiny bit cleaner in my opinion. It's part of Hadley's tidyr and dplyr packages. So we take a look at the restructured life, the restructured income, the restructured population, and it seems to have the form that we want, right? Country, year, and the variable, life expectancy, country, year, GDP per capita, country, year, and population. And so we can then merge these together, and we're going to use inner joins, okay? So what inner joins do is it says, okay, match, we're gonna combine like life expectancy and income, and it's gonna match, it's gonna find matching rows and combine the columns. So what it's gonna do is it's gonna take, it's gonna match up Afghanistan 1800 in this table and match it up with Afghanistan 1800 in this table, and it's gonna do that for every single row, okay? And there's 43,000, okay, so it's a lot, but it works very quickly, okay? So we just say combine that, and it's joining by country and year. The default settings are quite smart. If it tried to join by country only or something like that, we might have to say, hold on, try again, okay? But usually the default settings will work fine. And then here I'm going to then join population values to the table that's already combined there. Okay, and here I'm using a left join, okay? And the difference between an inner join and a left join and a right join and all of this stuff. So if you've ever used SQL, and if you haven't, that's okay, you can imagine trying to knit two tables together where maybe you've got names of people in this table and their informations, or in this case we've got countries and years in this table, years and life expectancy and population numbers over in this table. you have kind of the table on the left and the table on the right, or in your case it'd be the other way, right? Table on the left and table on the right. And with an inner join, it says, okay, if there's any rows in this table that don't match this table, or if there are any rows in this table that don't match this table, don't include those. Only include the tables that are matching. Okay, so it's like an intersection. So if you have, if you think of sets, it says, the resulting table is just going to be the intersection of the rows that match. Okay, with a left join, basically, if you have a Venn diagram, it's going to take everything in the left circle, which overlaps with the right circle, but anything that's in the right circle that's not part of the left circle will get discarded. A right join does the opposite. Everything in the right table that exists will show up. If there's nothing that matches in the left table, they get NAs. And then an outer join combines everything and puts NAs everywhere you need to be. Okay, so we've got inner joins and left joins, and so I'm going to merge that together using combined, and we can just kind of take a look at combined and just to make sure this table looks the way we want it to look. And just looking at it, it looks pretty good. Okay, it's got Afghanistan year 1800. The GDP per capita is 603 with a life expectancy of 28 and a population of 3 million or something like that. Okay. So life expectancy of 28, that sounds very low. Okay, and it is low, and that was the 1800s in Afghanistan. Now, this is not to say there were not old people back then. Okay. What was the problem was that people were born, these children were born, and many children would die within the first 1 or 2 years of life. Okay, that has dramatically changed in the last 100 years. Okay, but 200 years ago, couples would have lots of kids, fully expecting that many of their newborn children would die, and so that's why the life expectancy, this number, it's a life expectancy at birth, meaning if you survive, if as soon as you were born, you're kind of the lifespan, you would have this bimodal distribution, right? You'd have a lot of people or a lot of children dying at very young ages, and then people dying in old age, after they've survived kind of these most dangerous years. Okay, and so that's why you see such low life expectancy numbers. And then as soon as modern medicine kind of came in and managed to reduce this child mortality rate, this went down, and so the life expectancy average, really shot up at birth. Okay, so you see these numbers of like 35 years, and you're just like, wow, people just died at really young ages, but that's a little bit of a misnomer. Okay, all right. So anyway, we can then start creating our graphs. All right, so let's just, if we wanted to filter our data so that we're only looking at the year 2000, I can just say filter so that year is equal to 2000, and then I'm going to create a scatter plot here. Okay, and so the result of the filter goes into just kind of this temporary table called dat for data, and I'm going to use the ggplot command. So we'll load up ggplot2, the library, and the aspects that I want to plot on the x-axis will be GDP per capita, y will be life expectancy, and then we're going to kind of like in the Gapminder thing, we're going to have the size of the circle, proportional to the population. Okay, so we're going to say size is equal to population. All right, and the default settings, if I did geom point, is that it's going to plot, you know, these solid black circles, which aesthetically just is not that great. Like I'll remove these options here, and you can see what this will look like. So the default is this, and I get, this is kind of my default settings, and I get these solid black circles, which probably isn't not that great, okay? And so what I want to do, and we also see this thing, the income is it's a skewed distribution, so we get this funny appearance here. So we're going to, what we want to do is we want to add a few options. One of them is going to be use a scale, a logarithmic scale on the x-axis, which you just tell ggplot2 scale the x log base 10, okay? And that, it says, okay, I'll do that. And then, and I want to scale the size of our circles based on area. Okay, so the default is that it scales the radius of the circle or the point based on you know, your population. But here I want to scale the area of the circle based on the population. I'm going to set max size equal to 15. Okay, and so when I do that, I get this graph. Okay, and again the solid black circles may be less desirable, and so I'm going to apply these options, which basically just change the appearance of these things. Okay. All right, and so this is the graph that I have. If I wanted to go back and include kind of a continent or region column, I could do that, and we could color those like we have here, and say, you know, we could add another column to our data that says these are the regions that we have. We've got, you know, 5 or 6 regions, and we're going to color our data points as such. So, you know, this is kind of what we have, I think, at year 2000. I'm hoping the graph I have somewhat matches. And it does, and it's just that this one has much bigger circles. So I suppose I can, you know, max size this to like 35 or something, and we'll see what happens there. Is this, does this match closely? Somewhat, I think. It looks somewhat similar, I think. Okay, so we're getting something like this, and then, and the point that I wanted to do was do the animation, but unfortunately, that aspect is not working right now. So there is a cool package called animation in that works for R. Okay, and basically, what you feed this package animation is you give it a loop, okay? And the loop says, and each iteration of the loop produces a different plot, okay? So you can just imagine, like, you give it a loop, and, you know, so the first iteration of the loop plots the graph for the year 2000. The next iteration of the loop plots the graph for the year 2001, so on and so forth. And what this the package animation does is it takes each of those outputs, each plot, it kind of stores it as a different frame in the animation, and then the package then, you know, stitches it together into this nice little animated file, and it's rather cool. And if you were in my 102A class, you know, we had that Conway's Game of Life, and there was that GIF that I created. That was using the animation package. You just create a series of plots, and then you use the animation package to stitch them together. And I should be able to do that, but for whatever reason, I keep getting errors when I try I was trying it for like an hour, trying to get the settings to work. So I'm gonna keep playing with it, and I'll try to figure out what I'm sure it's just something stupid that I'm doing to get this, and we should be able to create a similar animated graph with this thing, okay? And I think if you can pull something off like that, I think when people saw Gapminder revealed 10 years ago, this was like hailed as some kind of revolutionary way to display information. I mean, there's nothing revolutionary about it. It's a scatter plot, right? It's a scatter plot, maybe with some animation, okay? But probably what was revolutionary was that we didn't have this kind of easily accessible data and visualizations readily available, and so you can create similar stuff with R using the tools that we have. And so I think it would be a fun exercise, and I'm still trying to figure out a homework assignment, but I think it'd be a fun exercise to have you guys create some kind of cool visualizations and such. So anyway, we'll end there today. I'll figure out this animation thing, and I'll post the working code and whatnot, or at least bits of the working code to get you guys going through it.